This is where optimal route reflection comes into play, because without optimal route reflection, 9 times out of 10, all paths are the same. And this lab this time is going to be about optimal route reflection. Now, I did a video on this before, but I just went over the theory, and now we're going to do it in the lab, and you're going to see the lab. This is a pretty intensive lab. Let me give you a warning here. You need to know about normal routing protocols, how disinvestor protocols, how link state protocols work before you can even do something like this. So let me explain how this lab actually works. So as you can see, I have 2 route reflectors here, and these are all iOS XRs. You can do this on iOS XE as well, but I just decided to do it in iOS XR. So we have 2 route reflectors. Then we have router 1, 2, and 3 are going to be my PEs that connects to this PE or this CE up here, which is technically in another BGP ASN. So this is going to be 65002 up at the top here, and these 3 PEs down here, which is 1, 2, and 3, are going to be in BGP ASN 65001. This whole thing here in yellow is 65001. And then we're going to have a PECE combo down here just for, labbing purposes. And this is going to be routers 5, 6, and 7. So what's going to actually happen is, and how I explained it in the theory before, is I am advertising a quad 0 down. So let's take a look here. And let's log in. And if I look at the BGP table, you will see that I am advertising this quad 0. This is technically a null route for demonstration purposes. But what I'm going to do is I'm going to advertise this quad 0 down to routers 1, 2, and 3. And if you look in the middle here, you're going to see a bunch of different cost values, right? Now, these cost values I put them in play to basically manipulate the path on how 5, 6, and 7 get to those quad 0. And this is where optimal route reflection comes into play. Because without optimal route reflection, 9 times out of 10, all paths are the same. It's going to go to router 1, right? If all paths are the same. But since I manipulated the path, the different cost values in ISIS for each link, what's going to happen is router 5 will pick router 1, because it's going to run, you'll see what I'm talking about.